Thanksgiving. So as a reminder, and I'll remind you throughout the week, we do not meet next Thursday. It's Thanksgiving break. So we only meet Monday and Tuesday next week. Now we move on to the crux of Calculus 1. The whole purpose of Calculus 1 was this one theorem called the fundamental theorem of calculus. It's broken down into two parts. The first part relates antiderivatives and integrals. However, when discussing the fundamental theorem of calculus, it is usually the second part we're referring to. In fact, it's really the second part that's of more interest. As part two is the evaluation theorem. It's how it gives us a method for evaluating an integral. So the function f is continuous over a closed interval a to b. Big F is any antiderivative of f. Then the integral from a to b of f is big F of b minus big F of a. So we want to evaluate this integral. First thing we need to do is find an antiderivative. Right? Remember, the theorem says any antiderivative. So we take what's known as the simple antiderivative. It's the one in which the constant is 0. Go term by term. 3x squared, antiderivative.
X cubed.
Antiderivative of 2x.
X squared.
Antiderivative of 1.
X. And let's add in a 0.
There's no need to write out the plus 0, so I just ignore it. Then that gets evaluated from x equals 1 to 3. Two ways. You could plug in 3 for everything, get a value. 1 for everything, get a value, subtract the 2. Or remember that integration is linear. So what I typically do is I just evaluate it term by term. So I'll look at x cubed and do that from 3 to 1. 3 cubed. 1 cubed. 27 minus 1. That's x cubed from 1 to 3. Three squared. 9. 1 squared. 9 minus 1. Oh, well, x is difficult.
Oh no.
3 minus 1.
2.
The integral's 20. I challenge you to do that using Riemann sums. Verify that you get 20. So much easier. At least for now.
Will we get to a point where doing it via the limit definition will be
Well, limit definition will never be easier.
okay.
Antiderivative of cosine.
Sine x.
That gets evaluated from pi over 2 to pi. Sine of pi minus sine of pi over 2 is what?
Oh, that's just negative 1.
There's your integral. But remember, what was the integral? What does the integral represent?
That's the space underneath the. It's in between the line and the x-axis. It's the area.
What line?
The line of the function.
Wrong term. Curve.
Ah.
Right, line is straight.
All right. Well, in any case, it's between the curve and the x-axis.
So area, not 100% correct. What type of area?
Must be signed area.
Signed area. So it's the signed area between the x-axis, the function, and those two vertical lines. Pi over 2 and pi. So the area is 1 square unit below the x-axis. That's the geometric interpretation. There's also a physical interpretation, which is net change. Whereas derivative is rate of change, integral is net change or total. Antiderivative secant squared x.
Tangent x.
We evaluate that from 0 to pi over 4. Hmm? What is it? Yeah, that's just 1. Antiderivative of 1 over x.
Natural log of x.
You're close. It's not natural log of x.
Natural log of x times x.
I agree it's natural log of something. For this particular problem, you're not incorrect. It will be natural log of x. But that's not the antiderivative.
Okay.
So what's that derivative? What's that derivative?
1 over negative x, or negative 1 over x. Oh, wait a minute, that's not allowed.
Yes, it is.
Oh, we can't have a negative in them.
Then x is less than 0.
Okay.
What is it? It's just 1 over x again. You forgot chain rule. Derivative of negative x is negative 1.
Okay, so the antiderivative 1 over x is the natural log of plus or minus x.
How do you represent plus or minus? Absolute value. So the antiderivative is actually natural log of absolute value of x. However, look at our interval. X is positive. which is why you can technically just say in this example, it's natural log of x.
Okay.
Bless you. Natural log of e minus natural log of 1. Oh dear.
Why not just be 1 minus 0? You already have it out.
Oh dear.
Natural log of e, that's just 1.
Right.
1 is e, right? No, wait, no, it says 0.
It's just 1. Natural log of e is 1, natural log of 1 is 0.
So a log of any base, 1 is,
Yeah.
it is 0.
Probably about to insult half of you, but typical engineer. Immediately reach for the calculator. Antiderivative, 5 to the x. What is it?
5 to the x over ln 5 plus c. That would depend.
5 to the first power? What is 5 to the minus first power? Simplify that.
Uh, 24 times the natural log of 5 over 5.
24 over 5 times the natural log of 5.
Should be 24 over 5 natural log of 5. That can still technically be simplified.
Over ln of 25.
Not 25.
Oh no, never mind. It's 5 to the 5. That's ugly though. 3,125.
5 to the 5th is 3125.
That really simplified.
Yeah.
I would posit the one before that looked a lot simpler.
Why, that has 2 terms in the denominator instead of just 1.
Yeah, but they're nice terms.
That can still technically be simplified further.
I swear we just take it back to 5 times natural log of 5.
I'll help you.
Would we ever actually do that in an applied setting? No. But if you want to get technical in terms of math, that is its most simplified form. So if there's just something like pre-calc and said fully simplify your answer, that is what you have to write.
Can we just rework exponents and square roots and or just roots in general and logs and stuff? We need to fix them.
Why do they need to be fixed? Make it sound as if there's something wrong with them.
Too different.
There's nothing wrong with them.
It's too different.
Is that a bad thing?
I just look at my answer. You're going to get an answer somewhere along the line of the dictatorship, so I'm just going to stop here.
Well, actually, in the dictatorship, being different is not good.
Yeah, that's how they know.
Just imagine if your entire family was exactly the same. How boring would your family be?
Well,
How boring would Thanksgiving be if everyone was exactly the same?
well, I am actually the fourth Edward in a row now.
Well, that's just name.
Yeah.
You're not the same as I'm going to say the third Edward. Right, since you're the one who started the numbering scheme. And stick with it. Right. And I'll assume the third Edward is different from you and the second and the first.
Yeah. Never actually met the first, but met the other two.
So it'd be a very boring world if everyone was the same. You can stick with that first one. I don't care.
Oh. How does the rule of log work with the natural logs?
What do you mean the rule of log work with the natural logs?
Like, how do you make ln of e24?
Well,
You forgot that?
Yes.
Hold on.
Change of base formula.
I'm asking, yeah, but like how?
Yeah.
Can you like,
well, if you throw in an extra natural log of e, that's just evaluates to 1. You can always multiply by 1. And 24 times a log is the same thing as throwing that 24 in the exponent.
oh, because it's a natural.
That's the
log.
change of base formula.
Oh, okay. I need the quite far out loud. I came to council. I'm not ashamed of my husband.
I'll just do what I do and have like a PNG of the log rules on my computer at all times.
How often do you look at them?
I think the log rules are also on the handouts.
They're in here somewhere.
Fairly certain they're also in the handout that I gave day one.
Yeah, I kind of forget that.
I mean, they might not be. I don't remember. I don't really look through it that often.
Yeah, well, I was in the year one, my entire 5.
It's on campus.
Yeah, well, it's a lot of work.
Oh, this one's challenging. This one's probably the hardest one we do all day. It's the antiderivative.
I'm gonna say yeah. Hold on. Well, unless you want us to approximate this, I think we should just leave our answers as e to the third minus e.
E cubed minus A. Which, depending on how you define simplified, that could technically be simplified by factoring it, but to me that's not simpler. Because that adds more terms. Because that could be E times E plus 1 times E minus 1. Which does not look nicer.
Apparently that's a bit over 17 right there.
Just a bit.
Well, a bit 17.3673. It could be closer to 17.
I thought it was going to be over 20.
Unless I'm doing something wrong.
That may be correct. I just thought it would be over 20. What is the antiderivative?
That would be the inverse of tangent x.
That is the inverse tangent of x. I love that because in Calc 2, everyone always forgets that and they try to do trig sum, which is not necessary. What is the inverse tangent of 1 without a calculator?
Well, that's either pi over 4 or no, that was 600 something here. 7 pi over 4?
It's a function, which means each input can only go to one output.
Okay, well, I do not remember the domain off the top of my head. Pi over 4?
Inverse tangent of minus 1.
3 pi over 4?
Negative pi over 4. Oh. There's a definition for pi.
It's the mathematical definition for pi right there. That's what that is.
There's no one single.
Okay.
There's a lot of them. I actually have a shirt that lists several of the definitions of pi.
So how do
You
you
have to wear that class today.
I wish I could. Sadly, it's so old that it ripped. I kept it. I just can't wear it anymore because it's ripped.
Yeah, can you just rearrange any formula that has pi and make it a definition?
That's why I said there's many. The most common one is the geometric one. Has to do with the ratio of the circumference to the radius, or diameter rather. Circumference to diameter. So slow to load. That's all there is to the fundamental theorem. Questions? And of course, it's going to get harder in Calc 2. Because finding antiderivatives gets harder. Edward. This one was a casualty. Sarah. Matthew Ronquillo. Dylan. Madison. Schubert. Nathan. Joseph. Eric Hassler. Garrett. Jake. Maybell. Kyle Joseph. Adam. Mary. Jonathan. Evan. Oh, is that a D? Oh, looked like a J. Evan Jack. Christopher. Matthew James. Ryan. Samuel. Sahil. Kieran. Brianna. Frank. Jonathan. Kevin. Matt Terrence. Oh, by process of elimination, Madison. So these ones did not go so well. However, overall course grade is still pretty good. I went through the course averages, and overall it's still really good. So that's good news. So obviously we have one more test, which is not comprehensive. It's just going to be on integration, actually, which is nice because there's not much in integration that we cover. There is one more project, which I oddly don't have up. Why is that not here? So with this fourth project, if you've looked at your groups, relook again, because I just changed them. Because I did have one person drop out, so I had to reorganize a couple groups. Also, yes.
Is exam 3 the same as the final?
It is our final, yeah. But it's not comprehensive, so it's going to be during finals week.
Right, so it's just.
Yeah, it's just on from week 11 through the end of the semester. And I think week 11 started integration. So it's just integration is how it happened to fall. You may not have to work on this project at home. Because I'm going to give you the rest of today to start it. And you get all of week, what's this week called? You get all of week 13. So next Tuesday and Monday after Thanksgiving, class time will be dedicated just to the project. I'm not covering anything those 2 days. So hopefully you won't have to work on it at home. You'll have enough class time to work on it.